Alright, hi everyone, welcome to my YouTube channel, TTF Elections. And in this video, we are going to work on this, okay, impulse response. In this video, we are going to work on this impulse response of a system. So, now before we talk about convolution integrals or sum, the idea of impulse response. Now, the idea is this, that once something is done to a system, once a system receives an input, what is the response? When the system receives input signal, or when the input signal to a system is an impulse signal, the response of that system to an impulse signal, that's what we mean by the impulse response of the system. It's just a simple way to look at it. So for convolution integral and convolution sum, this is what we mean. When the impulse response of a system is known, we can determine the output signal for any given input signal into the system. The convolution integral can be seen as sliding one signal, that is time reversed or over the image of a signal. Okay, so convolution is the process of sliding one signal over the shifted and folded version of another signal. Okay, so for continuous time signal, this is the expression for it. We are going to work some examples with it, and that will help you to get this expression in mind. Okay, so for discrete time signal, this is the expression for it. Alright, so now this guy x, these are the two signals, x of t and h of t. So x of x is time shifted here. Okay, it's time reversed and folded, like shifted and folded. That's the opposite. Minus is the opposite now, and this and time is added to it, so it's reversed and shifted, that kind of thing. Then h of lambda remains, then differentiate with respect to lambda from negative infinity to positive infinity. Okay, now from Laplace transform property, convolution in time equal multiplication in S domain. If we take convolution in time domain, this is in time domain. If we take this is convolution side. If we take convolution in time domain, it's the same as taking multiplication in the Laplace or in the frequency or S domain. Okay, so let's see some examples that will help keep this in mind. Alright, so while working with examples, it will help make more meaning to us as we work examples on it. Alright, now find the convolution of the following. X of 1 is this, x of 2 is this. So we'll just walk through them one by one. So let's take the first one. So the convolution of two signal x of 1, x1 of t, and x2 of t is given as that same expression we did in the previous slide. So from negative infinity to positive infinity, x of 1 is this, x of 1 lambda, x of 2. So the thing is one signal remains and the other signal is shifted and folded, or is folded and shifted. Okay, the lambda. Now we say x1 of t is this is not value given, x2 of t, this is the value given. So when we say the x of 1 convolution x of 2, where we have x of 1, you put this value. So this is x of 1, right? So now you put e raised to power 2t u of t. But anywhere you see t, you put what? Lambda. Are we together? So you put everything here, but you change where you have t to what? Lambda. So now it will be what? E raised to power what? Minus 2 lambda u of lambda dot multiplied by x2. Look at x2 value. This is x2. However, anywhere you see t, you put what? T minus lambda. Are we together? So exponential e raised to power minus 4 We have t, Abby, but I'll put what? T minus lambda, t minus lambda. U of t, right? But you now put t minus lambda. U of t minus lambda, t lambda. Okay? So that's that. Now, the next thing, since we've successfully substituted them, the next thing is to what? Do this. Now, this is u of lambda, which is this u of lambda. Okay? Now, unit step. Okay, that's 0 here. What about this? This is u of minus lambda plus t. Okay? U of minus lambda plus t. So minus lambda meaning the opposite of lambda, plus t will now shift the signal. So this is what? Folded and then shifted. Can you see it now? So we got this from this point, t minus lambda, okay, equals 0, which you can say, which you can say is what? Minus lambda equals minus t, which is what? Lambda equals t. Okay, which is t equals lambda at this point. Yeah, t equals what? Lambda. Okay, or lambda equals t. Yeah, but this expression we have inside here, t minus lambda, t minus lambda, you can see minus let me write here, minus lambda plus t. Just like we change the sign, like shift and sign reverse, that's what we have right here. Okay, at that point. Now, if you put these two signals together, okay, you shift or you put this signal on top of this signal. From this point, look at it. This signal, from here there is nothing, nothing here. Okay, so when you merge these two signals together, for this guy, apart from this point there is nothing. This guy at this point is nothing. So these guys, they meet somewhere here as the point we have. They meet at the point t. Okay, they meet at the point t. So lambda equals t at this point t. This is where they meet. Okay, so this line where we have lambda equals what? T. So at the point lambda, this is where we meet t. Then for this other guy, at the point 0, so we are going to move from what? 0 to what? T. So this will be our new limit. This will be our new limit from 0 to t. Okay, so thus the limit of integration becomes 0 to t. Are we seeing this now? Okay, for this first one, we just have lambda equals 0, no other thing. But for this second one, we have, which is what I did here. For this second one, lambda equals, so this should be our limit, 0. The shortcut, without drawing all this graph, you can just take the shortcut by saying lambda equals 0. For this case, you say t minus lambda equals what? 0, which is this. T minus lambda equals 0. Make lambda squared formula, you get lambda equals t. So this is your new limit, 0 and t. So the same thing you've written there, but you now say from 0 to t. Okay, from 0 to t. Now, here's for 2 lambda, here's for we cover this the lambda. Okay, so since we are differentiating with lambda, what we do here is this. Let me just write that thing out. This is integral 0 to t okay, so I just expanded this guy here. Okay, and it's the same thing as saying we now have this Okay, I hope you understand what happened here. So that's that, because this times this, you take one part and you sum what you have on top, which is this. So since we are differentiating with lambda, with respect to lambda, this 4 minus t will be removed as a constant. So we have 4 minus t outside. Okay, therefore we can now say, let me reduce this guy further, d lambda. So we'll now have use 1 minus 4t outside and lambda okay. I think we are there. Yes, we are. Okay, this time is minus 40, this time is plus 4 lambda. Okay, so this should be positive, that should be positive. Okay, so this guy e to power minus 40, which is e to power minus 40. Okay, 0 to t, 0 to t. Yeah, 0 to t, please, 0 to t, 0 to t. Okay, now differentiating with respect to lambda. So when you sum this, here will be what do we have here? Here we end up as minus 2 lambda plus 4 lambda. That will be what? 2 lambda. That will be 2 lambda. Okay, that will be 2 lambda, which is what we have here. Perfect. D lambda. So when you differentiate this with respect to lambda, you have what? This same thing divided by 2. Like this 2 will come down. Okay, which is why we have this 2 outside here to divide this guy. 2 will come down, but what we have on top will remain, and the limit is from 0 to t. So of course this lower limit, it's out already because that's 0. So everywhere you see lambda, you put what? T. So you have this guy here, t. Okay, so that's exactly how we do this part. Now yeah, so this is our final answer at this point. What they did, they just use this value to multiply what we have inside. Okay, and left my 1 over 2 outside. When this multiply this, you sum the what you have on top, and this plus this is what? Minus 2t. So e minus 2t, this times this will give what? E to power minus 40. That's how you get that. And this for values where t is greater than or equal to 0. Look at it, the range from 0 to what? T is greater than 0, and you can see it's from 0 because greater than or equal to 0. Okay, so that's that, t is greater than or equal to 0. Okay, u of t. So we just solved the first one, and this same method, guys, this same approach is what you do to number 2, number 3, number 4. Okay, so for the sake of time, I'm not going to do 2, 3, and 4. Okay, so in the next video we are going to the graphical procedure to perform this. So you can try out number 2, look at it, you can try out number 2, number 3, and number 4, and then let me know your answer in the comment section. And if you have any challenge with anyone, also let me know in the comment section. Okay, so just apply the same process to the rest of them and let me know, and I'll see you in the next video. Thanks a lot for watching, and bye for now.